Now we are going to learn about operators in Python. Operators in Python are special symbols or keywords that perform operations on operands. Operands are essentially values or variables that an operator acts upon in an operation. For example, let's consider the following Python expression, 10 plus 5. Here, plus is called the addition operator, and 10 and 5 are operands for the addition operator. As mentioned earlier, the operands in an operation can be values as well as variables. Here, a and b are variables, and for the addition operator inside the print function, they act as the operands. In fact, apart from the addition operator, here we have also introduced another operator, the assignment operator. The assignment operator, denoted by an equal sign, assigns a value to a variable. Like the addition operator, the assignment operator is also a binary operator, meaning that it acts upon two operands. In this case, the left-hand operand is the variable a that will receive the value, and the right-hand operand is the value 10, which is being assigned to the variable a. In general, the right-hand operand can be any value or expression that is being assigned to the variable on the left-hand side. So, for the assignment operator on this line, c is the left-hand operand, and a plus b is the right-hand operand, which is evaluated and then assigned to c. Now that we have a basic understanding about operators, let's formally look at the various types of operators in Python. We will explore some common types of operators available in Python. Arithmetic operators are used to perform mathematical operations, such as addition, subtraction, multiplication, division, etc. Comparison operators in Python are used to compare two values and return a Boolean result that is true or false. Logical operators are used to combine conditional statements or invert Boolean values. Assignment operators are used to assign values to variables. Unary operators are operators that operate on a single operand, like unary plus, unary minus, logical not, etc. Note that these are just the common operators in Python. There are also other types of operators, like membership operators, identity operators, and bitwise operators, which we will cover later. Next, we are going to learn about the common operators in a little more detail. Let's start with arithmetic operators in Python. Arithmetic operators in Python include addition, subtraction, multiplication, division, floor division or integer division, modulus operator, and the exponentiation operator. Let's look at each of them with a few examples. The addition operator, represented using a plus symbol, adds the two operands upon which it's applied. So in this case, when we add the two variables containing 10 and 5 using the addition operator, the output returned is 15. Please note that the operands for the addition operator can be other types of numbers also, like a floating point number. The subtraction operator, represented by a minus symbol, subtracts the second operand from the first operand. So when we subtract 4 from 10, the output returned is 6. Here again, as expected, the operands provided to the subtraction operator can be floating point numbers also. In this case, the value 10 stored in variable b is subtracted from the value 4.5 stored in the variable a. As expected, the output returned is negative 5.5. The multiplication operator, represented by an asterisk symbol, multiplies the two operands provided to it. So when we multiply 10 and 5, the output returned is 50. In a similar manner, when we multiply 4.5 with negative 10, the output returned is negative 45.0. Please note that the multiplication of two integers is an integer. However, if any of the operands is a floating point number, then the result of the multiplication is also a floating point number. The division operator, represented by a /, divides the first operand by the second operand. Also, the result is a floating point number. So, when we divide 10 by 5, the output returned is 2.0. Note that even if the number 10 is completely divisible by 5, the result is a floating point number 2.0, since the division operator always returns a float value. Similarly, when we divide negative 10 by 4, the output returned is negative 2.5. Sometimes, the result of a division operation is a non-terminating decimal value. In such a case, the float value shown in the result is approximated after a few decimal places. The floor division operator is also known as the integer division operator. It is represented by // and divides the first operand by the second operand and returns the integer part of the quotient. So, when we perform floor division of 10 by 5, the result is an integer 2. Similarly, when we perform floor division of 10 by 4, the result is again an integer 2. This happens because a normal division of 10 by 4 gives us 2.5, and the integer part of this would be the integer 2. In a similar manner, the normal division of 10 by 3 gives us 3.33 recurring. Therefore, the floor division for this would give us the integer part of the result, which is 3. The floor division always rounds the result of the operation towards negative infinity. We will better understand this using an example. We earlier saw that the floor division of 10 by 4 is an integer 2. However, if we perform the floor division of negative 10 by 4, then the result is negative 3. Let's understand why. You see, the normal division of 10 by 4 gives us 2.5. Therefore, the floor division of 10 by 4 would be the floor integer function applied to 2.5, giving us the integer 2 as the result. Similarly, for the other example, the normal division of negative 10 by 4 gives us negative 2.5. Now, the floor division of negative 10 by 4 would be the floor integer function applied to negative 2.5, which gives us negative 3 as the result. So essentially, we see that for positive numbers, this rounding down coincides with truncating the decimal part, which is not the case when the result is a negative value. As a side note, in some programming languages, the double forward slash is used for single-line comment. However, in Python, the double forward slash is used for floor division operation, and therefore, we use the hash symbol for single-line comment. Next, we are going to learn about the modulus operator in Python. The modulus operator, represented by a percent symbol, returns the remainder when the first operand is divided by the second operand. For example, for 10 modulus 5, the output returned is 0, as 5 completely divides 10, leaving no remainder. Similarly, when we perform 10 modulus 4, the result is 2, because when we divide 10 by 4, the remainder is 2. In a similar manner, when we compute 10 modulus 3, the result is 1. However, when we compute negative 10 modulus 3, the result we get is 2. Let's now try to understand the reasoning behind this. Let's say a and b are two given numbers, and r is the remainder when a is divided by b. Now, as per the definition of modulus operator, the result r should be such that the following equation holds true. Here, q is integer quotient. Also, r has the same sign as that of b, which is the divisor. In other words, the modulus result r and the divisor b should have the same sign. Essentially, the result r will be adjusted so that it falls within the interval from 0 up to, but not including b if b is positive, or b to 0 excluding b if b is negative. If most of this sounds complicated or confusing to you, let me tell you a simple trick that you can follow to compute the result of the modulus operator. You see, in this equation, the values of a and b are already given. So, in order to find the value of r, all we need is to find the value of q. Essentially, q is just the result of the floor division operator, which we have already learned earlier. So, q is given by the floor division operation a by b. Finally, we take this value of q and put it in the above equation to get the value of r. Let's test this with some of the examples which we saw earlier. So, as we saw earlier, when we compute 10 modulus 3, the result was 1. However, when we compute negative 10 modulus 3, the result we got was 2. We can easily understand this using the two equations that we defined earlier. In the first case, the floor division of 10 by 3 is 3, and when we put this value in the second equation provided above, we get the value 1, which is the final answer in this case. Similarly, for the second case, the floor division of negative 10 by 3 is floor function applied to negative 3.33, which is negative 4. And when we put this value negative 4 in the second equation, we get the value 2, which is the expected answer in this case. Finally, for the arithmetic operators, let's consider the exponentiation operator, which is represented using double asterisk symbol. The exponentiation operator raises the first operand to the power of the second operand. For example, when we have 10 exponentiation 2, the result is 10 raised to the power of 2, which is 100. In a similar manner, when we have negative 2 exponentiation 5, the result is negative 2 to the power of 5, which is negative 32. Please note that here, the parenthesis around negative 2 is necessary, which I will explain in just a minute. We take one more example to demonstrate negative exponents. Let's consider 2 exponentiation negative 3. The result in this case would be 1 upon 2 to the power of 3, that is 1 upon 8, which comes out to be 0.125. Finally, let's consider the need for the parenthesis around -2 in this example, as mentioned earlier. You see, there's a concept of operator precedence in Python, which we will learn later. If we have -2 exponentiation 4, then the exponentiation operator has higher precedence than the unary negation operator. This means that it is equivalent to first performing the exponentiation and then applying the negation to it, giving us the result -16. Therefore, in order to perform unary negation first, even with the exponentiation operator having higher precedence, we need to wrap the -2 in parentheses like this. This will first apply the negation and then perform the exponentiation on it, giving us the result 16. This concludes the arithmetic operators in Python.